So I have practice exams for you, and if you have any questions in the meantime, email me. But tonight during lab, we'll also be able to go over a lot more. I think the esterification lab that we do, working with the models really helps you understand how this reaction is taking place. So, okay. So in our note packet, we hadn't gone over amine solubility, right? Okay, so amines with less than 6 carbons are soluble in water. With amines, and we'll cover this later on, there's something that goes on with hydrogen bonding. And so hydrogen bonding makes them more soluble, so that's why you can get away with 6 carbons instead of 4 carbons with the carbonyl compounds. So the next thing we're going to learn about is amidation. And what functional group do you think forms when you run an amidation reaction? What did you say? Yes, very good. So when you run an amidation reaction, it's a dehydration reaction. And the other dehydration reaction that we've seen is what? Yes. So it's like esterification. Instead of forming an ester, it forms an amide. So in order to form an amide, you need a carboxylic acid. So in this case, you have acetic acid. How many carbons are in acetic acid? 2. Excellent. So you have 2-carbon carboxylic acid. So you have your carboxylic acid. This would be a great true-false question. Right? Carboxylic acid reacting with an amine makes an amide. True or false, that type of thing. So if you can kind of go through your notes and make up your own exam with true-false questions, multiple choice questions, that can be helpful too. So to form an amide, you need a carboxylic acid and an amine. So methylamine, how many carbons are in methylamine? 1. So I'm going to write it this way. Is this a primary, secondary, or tertiary amine? Primary. Good. So it's a primary amine. Now, I'm not saying that every amine has to be primary in order for these amidation reactions to occur. In this case, it's just a primary amine. So, how did we lose water in esterification? OH? So you get rid of the OH here.
1H on the other side.
1H on the other side. Make a really long bond. So you're essentially doing the same reaction as esterification. But instead, you just have an amine. So they both have a carboxylic acid, but they have a different. Esters have an alcohol, amides have an amine. So this is your amide. We'll see this bond again in Unit 6 when we talk about proteins. So that peptide bond, that's what holds proteins together. Now we've learned about how amides are formed. Now we're going to learn how to name them. And it's kind of a little bit of ester nomenclature and a little bit of amine nomenclature put together. And that's how you name amide. So, yeah, we have the same. This is the same amide here. There are two ways to name amides, just like everything we've seen. Drive me crazy.
Just pick one.
Just pick one, yes. No, we don't do that. But like always, IUPAC is the longest continuous chain of carbons. The ending is going to be amide. You're going to get rid of that E on your alkane. And because you have this nitrogen group attached to this carbonyl, you're going to have to say in alkyl if it's in methyl or in dimethyl. So just like with esters, I always encourage students to square the alkyl group, circle the parent. Now your parent with amides has a carbonyl nitrogen. Carbonyl nitrogen. So you're counting how many carbons are here. So this is your parent chain. So how many carbons are there? 2. So what root or what parent name would that be? Yeah, ethane. Good. So ethane. Take off the E. Add the amide. Now, we need to address this squared group. It's attached to the nitrogen. So you're going to put in, and what's the alkyl group? Methyl. Good. So in methyl. So we know how to name esters, and we know how to name amines, and really amides are just those two names put together. So in methyl ethanamide would be the name.
So the N kind of is like a number in a sense.
Exactly. Mm-hmm. And when you see N, that just means it's coming off the nitrogen. So the N is like a number.
Now, will we have any that have 2 of them, or we'll have to one at one and one at the other? And
No, they exist.
no, so no di.
Amides. What's that? Yes. Yeah, we'll have some practice. So, okay, with common, what are the 2 roots that we know for carbonyl compounds? Good. Form and acet. So form is 1 carbon. Acet is 2 carbons. And so just like you did over here, you're going to do your squaring and circling the same way. And you're even, and I should put in alkyl, add that, in alkyl. So you still put the in methyl or the in dimethyl, depending on how substituted your amide is. But this is going to be in methyl. And instead of ethanamide, it's just going to be acetamide, right? Yeah. I can write it, but I can't say it. So N-methyl acetamide would be the correct name. So I have practice nomenclature, practice reactions. And I want to go over the center one. What functional group is this? Ketone, but it has that nitrogen. Yes, it's an amide. Very good. So this is an amide. It doesn't have any substitution on this nitrogen, but it's still an amide. So you can see, just like amines, amides have a lot of different looks. They can be NH2s, they can be NHs, they can be just Ns. So depending on how substituted your amide is, it can look like this. This would be a highly substituted amide. This one is not highly substituted. It's just a basic amide.
So that one below it with the two, is that where you do like in dimethyl?
Dimethyl, yes. Exactly. So I wanted to point out this amide. A lot of times students miss it on quizzes or exams because you think, what is that? Is it a ketone? Is it amine? This is surely not an amide, but it is. So the way you go about naming it, so that's your parent. You don't have any in methyl and in dimethyl. So how many carbons are in this? 2. So the IUPAC name would just be ethanamide. And then the common name would be, yes, acetamide. Very good. So this would be your simplest amide, right? No substitution. These amides, they have an H right here. H right here. So that is going to have one substituent. So it's going to be in methyl, in ethyl. These don't have any H's, so it's just in dimethyl, in dimethyl. And this one is just unsubstituted. So I want you to try naming these. Maybe I'll work one more with you. Is there one that you want me to work with or demonstrate first? The last one? The last one? Where is your amide? What's the parent? The right side? Okay. So that's your amide.
Oh, because of the O.
Yeah, this is an O right here. So it would, if there wasn't this O here, it would be 1, 2, 3, propyl. But there's an O here, so that makes it propoxy. Yes. So propoxy. Yeah, this. You know you're delirious when the names in Unit 4 just make you start laughing. Like, oh my gosh, what next? So this is propoxy. That's your substituent. And your parent is here. How many carbons are in my parent? 3. How would I number my parent? Right to the left, right? Because this carbonyl is very important. You have to respect that carbonyl. So 1, 2, 3. Okay, so a 3-carbon parent, that would be propane. What ending would you add to it? Yes, good. Very good. Bless you. So off the 3rd carbon, what do I have? 3, propoxy, propanamide. Not a very pretty name. Yeah, it's pretty harsh. Propoxy. Okay, so
What is that? Is that what?
IUPAC.
Or what?
I'm not sure. A lot of these chemicals, sometimes we just. What rules do we know how to name? You know, because some of the chemicals like that you are familiar with would be hard to name. So, based on our rules. So I want you to work on naming these 4. Remember to take a deep breath and just try to think about it as simply as possible. Try to identify the parent. Try to circle and square. And that will get you really far with amides. Okay, so I'm just going to check your squaring and circling. This is a square, circle, square, circle, square, square, circle, square, square, circle. If you found yourself squaring or circling anything else, differently, then you will probably end up with a different name. So this first one, 2-carbon alkyl group, what would that be? Ethyl. So N-ethyl, 1, 2, 3, 3-carbon parent with an amide. Good. Propanamide, yeah, you're not.
You know what I mean?
This one on the far right, does anybody remember this from their orange flashcards? Good, benzamide. So N-methyl, benzamide. And remind me at the end of this to go through your aromatic names. Just a little review.
On that one, it does not have one action that needs to be attached to the hydrogens. Like on the one flashcards.
No.
Thanks.
I'll address that. All right, this next one, N,N-dimethyl ethanamide. And then the common name would just be N,N-dimethyl.
Expialidocious.
Yes,
Exactly.
acetate. All right, so N,N-dimethyl. Methanamide, because it's 1-carbon parent. And then the common, what root would you use? Form. So N,N-dimethyl formamide. So I know at first, amides, it takes you a while to get used to naming these. But now when you're practicing, as we're getting nearer to the end, make sure that you're practicing naming everything together, right? Your alcohols, your thiols, your ethers, your aldehydes, your ketones, esters, amines, amides, all of them together, because that's how they will be on the exam. So in the pink book, we do have practice problems that are all mixed together. All right, the last part of this packet, complete the following reactions with reactants and products. These are amidation reactions, and so, it's a carboxylic acid plus an amine, and I have you name them for practice. On the exam or on a quiz, it's likely that I'll just ask you to complete the following reaction. You don't have to name in addition to that. And sometimes students, get thinking, oh, I need to name all these products for my reactions. No, not unless it gives you explicit instructions, and it would be very atypical if it did. So when you're completing your reactions, don't worry about naming them. I just do it in the note packets to give you more practice on naming. Okay, acetic acid. How many carbons are in acetic acid? 2 carbon, carboxylic acid. And see, that's a common name for a carboxylic acid. So this is like you could see on the exam. I could give you a common name, and you have to know it, even though you may prefer to name carboxylic acids with IUPAC. All right, methylamine. How many carbons in methylamine? 1. So CH3, NH2. How do I make an amide from these two reactants? That's excellent. Yes, exactly. So you end up with all right, tell me where to square, tell me where to circle. Square the CH3. Good. And then circle all the rest. Excellent. So now that it's squared and circled, hopefully it's easier to name. So the square is in methyl. And I didn't specify whether I wanted IUPAC or common, so you name it however you want it. Good. In methyl, ethanamide, yes. No.
I feel like it's a semester. I thought it would be a good idea to take a hair break.
Oh. Wow. That's a really tough class.
Yeah.
All right, so we have acetic acid again. 2-carbon carboxylic acid. Isopropylamine. What does that look like? CH3, CH, CH3. I know. Yeah, those alkyl groups that you're trying to forget from Unit 3, you'll see them again in Unit 4. So, by the time you get them for Unit 4, they'll stick much better when you're studying for the final. Okay, so we're going to do the same thing. Get rid of the OH on the carboxylic acid. Get rid of the hydrogen on the amine. Make a really long bond. We're left with NH. And then you can rotate these bonds however you want them, however much space you have. So I'm going to go like this. What do I square? What do I circle? Right, so square, it's really more of a rectangle, and then circle, oval. Okay, so what alkyl group is that? Isopropyl. In isopropyl. 2-carbon parent, that's going to be acetamide, ethanamide. You got it. All right. With a few more. Okay.
I thought I heard you say something else, but write something different.
Oh.
I was confused.
In isopropyl acetamide or in isopropyl ethanamide. So it could be
Two different pages.
acetamide.
So the bottom one's the
Common.
or common.
Acet. You'll get it. All right, on the next page, I have a few more, and not every one of them I want you to name. D, I want you to name, but not C and E. So 2-methyl-butanoic acid. How many carbons in that? 4. Carboxylic acid. And I have a methyl on the alpha, beta, or gamma carbon. Alpha. Remember, this one's alpha. And this is just, I'm just reviewing.
Oh, that's right. You don't include the first one.
Right. So so the methyl is on the alpha carbon, which is carbon number 2. And then ethylmethylamine, CH3, CH2, nitrogen. So you end up with 1 H on your nitrogen, which is nice because we need 1 H to carry out this amidation reaction. So get rid of the OH, get rid of the H on the nitrogen, make a really long bond. And this one you don't have to name. What does benzoic acid look like? Benzene ring. And then dimethylamine. What does dimethylamine look like? Two ethyls or two?
One carbon.
Good. Okay. Go to your OH. Go to your other H. Really long bond. And you end up, and you could put a circle in this cyclohexane if you wanted. Just make sure you either put a circle or the alternating single and double bonds. What do I circle? What do I square? Good. And circle the rest of it. So this is the one that's going to drive Josh crazy from the orange flashcard.
Still be an
No, there's only one each.
You only had one each, yeah.
Oh, sorry.
So nitrogen just has 3 bonds.
So it's
NN dimethyl
Been-
benzamide. And these little spelling things where you leave things out, it will get better, you know, as you're accustomed to looking and practicing this stuff. All right. Does anybody know what the formula is for ammonia? It's NH3. Ammonium is NH4 plus. Yeah, which is a great review from Unit 2. Yes. Don't forget those polyatomic ions. You'll need them. You'll need them soon. Okay, 2,3-dimethyl pentanoic acid. How many carbons? 5. Carboxylic acid. 2. So off the alpha and beta carbons, you have methyls. So then you go to your OH, get rid of 1 hydrogen, make a really long bond. NH2.
I'm going to test all of just those.
You can do the reaction. Yeah. All right, so I'm going to do a little itty-bitty review. So if we can find maybe an extra piece of paper or at the bottom of your page or the back of one page. So we have pretty much everything in Unit 4 can be divided into 2 things. Nomenclature or reactions, some properties. You solubility properties, so I got it, 3 things. But the big ones are nomenclature and reactions. So we were just talking about amidation, that's a reaction. Let me go over your reactions in a nutshell. Remember we started off Unit 4 with alcohols getting oxidized. So primary alcohols cannot get oxidized to what? Yes, very good. Okay, secondary alcohols get oxidized to what? Ketones. Tertiary alcohols, no reaction. And then we have two more oxidation reactions where we have an aldehyde getting oxidized to a carboxylic acid. And then we have a ketone Will the ketone be oxidized? No reaction. Good. So those were the first set of reactions that we learned about, oxidation reactions. Then we learned about the reverse, reduction reactions. What are the reagents with reduction reactions? H2 and a catalyst. Good. So we can have an aldehyde, platinum, palladium, something written over the arrow, and you end up with a CH2OH, a primary alcohol from that reduction reaction. The other reduction reaction that we learned about was a ketone being reduced. So ketones can get reduced. They can't get oxidized. So you end up with a secondary alcohol. They spelled out with a K. So I would say one of the most commonly missed reactions on exam 4 involves ketones. So watch out for these. A lot of students want to say that ketones cannot get reduced. They say no reactions. But it's that ketones can't be oxidized. That makes sense? So be careful. Right, the other reactions that we learned about, dehydration reactions, we learned 2. So a carboxylic acid plus an alcohol. So carboxylic acid, alcohol. Get rid of the OH, get rid of the H. What functional group do you form? Ester, yes. Very good. So you square this, and circle that for the name. All right. What's the other dehydration reaction we learned about? The one tonight. Good. Excellent. So it also involves a carboxylic acid and an amine. So the amine must have one hydrogen. It doesn't say, whether these need to be carbons or hydrogens. We just have to have at least one hydrogen for the amidation reaction. So we have a carboxylic acid, we have an amine, we get an amide. So these are all the reactions that we've learned. So 1, 2, 3, 4, 5, 6, 7, 8, 9 reactions. And then we learned 9 functional groups, the nomenclature for 9 functional groups. So I wanted to go over, just as a review, aromatics. What's the name of that one? Phenol, yes, yeah, very good. Phenol. It's phenol. Then aniline. Now, aniline can have a lot of different looks. This is aniline. This is also aniline. So this is N-methyl aniline. Or you could have N-dimethyl aniline. Right, I know, it throws you for a loop. But now you're prepared. You're going to get it. You'll see it. So, let's see. What other ones do we have? What about what's that one called? Benzoic acid. What about that one? Benzaldehyde. Square this one, circle this one. So what's that? Methyl benzoate. Benz what? Benzamide. Yes, you're saying, yeah. You got it. That's benzamide. And then dimethyl. Yes, and excellent. N dimethyl benzamide. Mm-hmm. So, 1, 2, 3, 4, 5, 6, 7. If I have a benzene ring coming off a chain of more than 6 carbons, then this is called phenyl. But if I had the benzene ring, this kind of goes back to Unit 3. If I had a benzene ring with 4 carbons coming off of it, who gets the parent? The 4 carbons or the benzene? The benzene. So it's going to be butyl benzene. So the parent, butyl benzene. So this is 6 carbons versus 4 carbons. That's why benzene is the parent. This one is 6 carbons versus 7 carbons. That's why this would be 2-phenyl heptane. That's why heptane.
Is it always 6?
I have